In this video, I'll be showing what the kinematics equations in physics are, how to derive them, and one basic problem that demonstrates its usage. So first well let's so So first, let's learn what it means. So kinematics is the branch of study in physics called mechanics, where it just deals with how stuff happens. So this is what it deals with, but it doesn't deal with why. So yeah. And basically, wait. So basically, the kinematics equations is really important. Is a really important set of 4 equations in physics, and it helps us solve for a lot of mechanics problems, and it helps us solve for things such as velocity, speed, acceleration, time, displacement, etc. So basically, just for a quick clarification, in case you didn't know, displacement. Oh yeah, you can also help find distance. So displacement is the distance your position is with respect to your starting reference point. Distance is the whole length covered. Time is how long it took. Acceleration is speeding up or speeding down, so basically the change in rate over time. Speed is like rate, how fast, and velocity is speed with direction. So yeah, and velocity has vectors, and so does acceleration. So now let's start. So first, the most basic things you need to know to be able to basically the only things you have to know to be able to derive the kinematics equations is the following formulas. Speed equals distance over time. Velocity equals displacement over time. And acceleration equals velocity over time. Average velocity equals v0 or v initial plus v final over time. So basically, before we start, let me first introduce the notation I'm gonna use. So basically, I'm gonna represent all the initial states of each variable. So like these. So these are all variables of each variable with the subscript 0. So for example, the initial velocity would be denoted as v0. The initial like position would be x0, and etc. And the reason I'm using 0 is because it shows, like for example for v0, it shows the velocity when time equals 0, because it's the initial state. And then wait, and also I'm gonna represent the final ones. I'm gonna represent final states with just the variable. For example, I'm gonna represent final velocity as just this with no subscript. So yeah. And so basically, first let's have like an overview of the kinematics equation. So basically, it's 4 equations, and the equations are for like the on the left of the equal sign. There's an equation with v on the left of the equal side, which is speed, and there's one for v squared, and there's 2 for displacement. And basically the one for that has v on the left hand side, it usually tells us information about acceleration because it's part of the equation. The one with v squared is similar to the one with v, but it has displacement in it. And the one of the displacement equations, it just tells you a lot about like velocity and time and acceleration, and so does the other displacement equation. So yeah, let's get started. So let's start with the first equation. The first equation is derived from the fact that acceleration equals velocity over time. Notice that using if we look back at this notation, we find that we can represent v we can represent this velocity over here as v minus v0, and then we just divide this by time. And then we multiply both sides by t to get v minus v0 equals a t, and then we add v0. Oh yeah, v0 is the initial state, as said, in case you forgot, to get v equals v0 plus acceleration times time, or final velocity equals the initial velocity plus the product of the acceleration and elapsed time. And yeah, so this equation here, this final equation we got, this is our first kinematic equation. Now let's move on to the second one. The second one is I think it makes sense to now do the other v1, which is the one with v squared. And the v squared one, it's essentially just squaring this equation. But what makes it different from what makes this v squared equation different from this equation is that v squared equation has displacement in it. So if you know displacement, if you know the displacement and you want to find the velocity, then this equation is convenient. So just v0 squared plus 2 times v0 times at, which simplifies to v0 squared plus, and notice that v0 times t is displacement, since velocity equals displacement over time, so displacement equals v0t. So we have this. Oh, and this is v squared. And this is literally our second kinematic equation. So we finished half of them already. Now let's move on to third. Now the final two equations are about displacement. So this third one, so basically we first derive it from the fact that displacement equals velocity. Sorry. I meant velocity equals displacement over time, as said here. So now notice that we have another equation with velocity in it, which is this one here. So basically we have displacement over time equals initial velocity plus acceleration times time, which gives that displacement equals so displacement would equal v0t plus acceleration times time squared. But notice that this actually isn't the final one, because since we're finding the final displacement, we have to wait. No, since we're finding the final position, we have to include the initial position in it. So we have x0 plus v0t plus acceleration times time squared. But then when we do this, we also have to use this equation here, which tells us that we have to divide this at squared by 2. So our final one is position equals initial position plus this plus 1/2 at squared. So this is our third equation. Now let's move on to the last. So the last one is actually like relatively simple. It's just finding velocity. So basically we know that velocity is so this one is trying to find average velocity, and we can just write that in terms of the speeds. It's just your initial speed plus your final speed over 2. That's literally the average. And that's literally just this equation. So yeah, this is our final kinematic equation. So that will finish all the kinematic equations. So let me summarize. So first, we have speed equals initial speed plus acceleration times time. Number 2, position equals initial position plus the initial velocity times time plus half of acceleration times time squared. Number 3, v squared equals the initial velocity squared plus 2a times 2 times acceleration times the displacement of x. Also note that if you want to break like this kinematic equation is already enough, but if you want to break it down even further because you have like multiple displacements in the problem, then you can do v squared equals v0 squared plus 2a, and then we write displacement as final position minus initial position. This also works. But this is also enough. It's just that if you have more information, you can use this. And the fourth and final one is velocity equals initial speed plus final speed over 2. So yeah, those were the kinematic equations. And yeah, so basically using kinematic equations, we can like do like find out a lot of things in mechanics, because it tells us the relationship for velocity, speed, distance, displacement, time, and position, etc. And these are the very important things in mechanics. So the kinematics equations are really useful for this. And I'll be posting another video later that has like a application problem of these kinematics equations. It's likely gonna be a FMA problem or something, but I'm not sure yet. So yeah, thanks for watching, and make sure to like and subscribe and comment down below, and turn on notifications for this channel.